Hi, we are Lisardo Villasante Fernandez and Iago Balsa, and we are going to present shell shaping and the involved structural challenges in their construction and maintenance. I am thrilled to talk to you about the fascinating topic, shell shaping and the involved structural challenge in their construction and maintenance. This presentation is aimed at providing an in-depth look at the complexities involved in creating and maintaining shell structures, which are crucial elements in modern architecture. The first slide is the introduction. To start, let's set the stage by discussing what shell structures are and why they are so significant. Shell structures are essentially thin, curved, three-dimensional forms that efficiently distribute loads across their surface. Unlike traditional structures, which often rely on a framework of beams and columns, shell structures use their entire surface to bear loads. This characteristic not only makes them incredibly efficient in terms of material use, but also allows for the creation of visually stunning and architecturally unique buildings. Their importance in modern architecture and civil engineering cannot be overstated. Shell structures are found in a variety of applications, from large span roofs and bridges to art installations and even biological analogs. They offer both structural efficiency and aesthetic beauty, making them a popular choice for architects and engineers looking to push the boundary of design and functionality. Throughout this presentation, we will explore various aspects of shell structures, including their design principles, construction challenges, and maintaining issues. The definition and types of shell structures. Now let's delve deeper into what defines a shell structure and the various types that exist. Shell structures are characterized by their thin, curved, and continuous surface, which can span large areas without the need for internal supports. This is achieved through their geometric properties, which allow them to distribute loads efficiently across their surface. There are several types of shell structures, each with unique characteristics and applications. Simple shell structures include forms like domes and vaults. Domes are often used in buildings like sports arenas and churches, that due to their ability to cover large areas with minimal material. Vaults, on the other hand, are elongated structures that can span long distance, making them ideal for tunnels and large hallways. Complex shell structures, such as hyperbolic paraboloids and snail shells, offer even greater design flexibility. These forms can create visually striking and structurally efficient buildings. Hyperbolic paraboloids, for example, are used in avant-garde in architectural designs due to their unique curvature strength. Snail shells, inspired by natural forms, demonstrate how biological principles can be applied to structural engineering to achieve both beauty and functionality. Design shell structures require a careful balance between strength and material efficiency. One of the key principles in shell structure design is the use of curved forms, which help to distribute loads evenly across the surface. This not only maximizes the structure strength, but also minimizes the amount of material needed, leading to more sustainable construction practices. Materials used in shell structures are typically lightweight, yet strong, such as reinforced concrete, which offers both the flexibility needed for complex shapes and the durability required for long-term performance. The choice of materials is crucial, as it directly impacts the structure's ability to withstand varied loads and environmental factors. Modern design of shell structure heavily relies on advanced software for structural modeling and simulation. These tools allow engineers to create precise models that can predict how a structure will behave under different conditions. By simulating loads, stresses, and deformations, engineers can optimize the design for both performance and costs, ensuring that the final structure is both efficient and safe. Constructing shell structures comes with its own set of challenges, primarily due to their geometric complexity. Creating and assembling precise curved shapes requires advanced techniques and a high degree of accuracy. This often involves using custom formwork and molds, which can be both time-consuming and expensive to produce. The complexity of these shapes also means that even small errors can have significant impacts on the overall integrity of the structure. The cost associated with the construction of shell structures can be substantial. High-quality materials are often required to achieve the necessary strength and durability, and the labor involved in constructing complex forms can also be quite intensive. Furthermore, the need for specialized equipment and techniques can add to the overall expense, making it essential to carefully plan and budget for these projects.
Another major challenge in constructing shell structure is ensuring that they can withstand various loads and remain stable under different conditions. Shell structure must be designed to handle not only the weight on the structure itself, but also additional loads such as wind, snow, and seismic activity. Proper load distribution is critical to prevent structural failures, which can have catastrophic consequences. Innovative construction techniques are often employed to address these challenges. For example, special formwork and molds are used to create the complex shapes required for shell structure. These techniques require a high level of skill and precision to execute properly. Additionally, advancing material science and construction technology have made it possible to create more complex and efficient shell structure. But this innovation also comes with their own set of challenges and costs. Once a shell structure is built, maintaining it over time presents its own set of challenges. One of the primary issues is material degradation. Over time, material usage in shell structure can deteriorate due to factors like corrosion, environmental exposure, and wear and tear. This can weaken the structure and lead to safety concerns if not addressed promptly. Inspection and monitoring of shell structure can be particularly difficult due to their complex shapes. Traditional inspection methods may not be effective, and specialized equipment and techniques are often required to thoroughly assess the condition of the structure. This can add to the overall maintenance costs and make it more challenging to ensure the long-term safety and functionality of the structure. Repairing and reinforcing shell structure is another major challenge. Maintenance methods that must not only address any structural issues, but also preserve the aesthetic and integrity of the structure. This often requires specialized techniques and materials, which can be both costly and time-consuming. The high cost associated with regular maintenance and specialized repair work can be a significant burden for owners and operators of shell structure. However, regular maintenance is essential to ensure the safety and longevity of this structure. This makes it important to plan for ongoing maintenance and budget accordingly to avoid any potential issues down the line. Let's take a closer look at some notable examples of shell structure and the challenges they have faced. The Sydney Opera House is perhaps one of the most iconic shell structures in the world. Its unique design and complex construction presented numerous challenges, from creating the precise curved shapes to ensuring the structure could withstand various loads. Maintenance of the Sydney Opera House continued to be a significant task, requiring specialized techniques and material to preserve its structural integrity and appearance. Another example is the Philharmonic de Paris, a contemporary shell structure that also faces its own set of challenges during construction and continues to require careful maintenance. The complex shapes and material uses in the Philharmonic de Paris is a prime example of how modern shell structure can push the boundaries of architecture and engineering while also presenting significant maintenance challenges. This case study highlights the importance of innovation and precision engineering in the construction and maintenance of shell structure. They also demonstrate the ongoing committed required to maintain this structure and ensure their continued safety and functionality. In conclusion, shell structure offers significant benefits in terms of both strength and aesthetic appeal. However, they also come with considerable challenges in both construction and maintenance. The geometric complexity, material requirements, and costs associated with this structure require careful planning and execution to overcome. It's essential to innovate and apply precise engineering techniques to address these challenges and ensure the longevity and safety of shell structure. By doing so, we can continue to create remarkable architectural works that not only stand the test of time, but also inspire future generations. Thank you for your attention, and we hope that you found this presentation informative and thought-provoking.